We can dive a little bit into more formal math to show why this works. We can rewrite our fixed point numbers as being an integer times the power of 2. The power of 2 is the negative number of fractional bits that we have in each one. So we'll say 2 to the negative n for this example. We can then write our addition as a times 2 to the negative n plus b times 2 to the negative n. That lets us factor out the 2 to the negative n and end up with a plus b times 2 to the negative n. That just shows what we said before. We can add a and b together, and the result will have the same number of fractional bits. But do note that to be able to factor out the 2 to the negative n, both a and b had to use the same number of fractional bits, in this case n. Now let's take a look at multiplication, but in this case we won't assume that they're using the same number of fractional bits. We'll say a has n fractional bits and b has m fractional bits. The expression then becomes a times 2 to the negative n times b times 2 to the negative m. If you remember your exponent rules, we can combine the powers of 2 by adding their exponents together, so the expression becomes a times b times 2 to the negative n plus n. This means that when you multiply two fixed point numbers, the number of fractional bits in the result is the sum of the fractional bits of both operands. For example, if we took a value with 2 fractional bits and multiply it by a value with 2 other fractional bits, the result would have 4 fractional bits.